All right, in 11.4, we're going to continue working with our exponential functions, and we're going to use more word problems. So it's a little bit of a continuation of what you saw back in 11.2, except in 11.2 in your word problems, you had things like the number of people double each year. And because you had the word double, you knew that you were using a 2. So depending on how many people there were to start with, maybe it says there are 10 people. So because you're starting with 10, your equation is y equals 10, and then you're in parentheses 2 to the power of x, because this was your starting amount, and this is how much you are increasing or decreasing by each time. And so in 11.2, all of your word problems had one of these keywords or key phrases. It doubles, it triples, so you would put a 3 here. There are half as many people, so you would put a 1/2 in here. And so that was how you did 11.2. In 11.4, we're going to focus on word problems that have rates as percents. So instead of saying that it doubles every year, it might say it increases by 37%. Okay, so first we need to recall how to get a percent to a decimal. Okay, because you can't use the actual percent in your equations. If I say that you are increasing by 37%, you can't use the number 37. You have to use 37% as a decimal. So when you have a percent, it's out of 100. So just like any score you get in class, when you get a 57%, it's a 57 out of 100. When you get a 92%, it's a 92 out of 100. So percents are just dividing by 100. So when I have a 37%, it's really 37 divided by 100, which just tells you that you need to move your decimal place, which is currently right here after the 7. You need to move it 2 places because there's 2 zeros to the left. So 37% is 0.37. Okay, so it's just moving your decimal place from wherever it currently is 2 places left. So if I said 75%, what's that as a decimal? Well, your decimal's right here. Move it 2 places to the left, which means 0.75 or 0.75. Okay, we're going to go through a couple of more so that you can see a little bit more practice of that. If I said 6% as a decimal, okay, your decimal is currently here. You need to move it 2 places, 1, 2. There's this imaginary 0, so 6% is 0.06. Okay. What if I said 42.3% as a decimal? Well, take your decimal in its current location, move it 2 places to the left, which gives you 0.423. Last one, hopefully you're starting to get the hang of this. If I have 3.7%, take your decimal, move it 2 places, and there's this imaginary 0 again. So it's 0.037. Okay, so that's something you'll need to make sure that you are able to do. We'll do a couple more, you'll see a couple more of examples together with us as we start working on our word problems and our percents. So from 11.2, we had this form of our equations, y equals a b to the x, where a is your starting, and B is basically it's how much you're changing by, how it's changing. So when you start with 10 people, you put 10 in the front, and if it's changing by doubling each year, you put your 2 inside the parentheses. If it says you have $300, you start with $300, and it's cut in half each year, you put a 0.5, so you'd have 300 because you're starting with 300, and then 1/2 or 0.5 because it's half as much each year, and then to the power of x. In 11.4, we have an equation form that is very similar, that you need to make sure you get written down for today's lesson. Y equals A, and then in parentheses it is 1, and then this plus or minus sign that you have seen before, R, all to the power of x. Okay. Now let's talk about what each of these variables mean, y, a, r, and x. So y and x are your variables that will stay variables, but I want you to know what they usually represent. Typically, y represents the future amount or future value. So your word problem might ask you, how many people will there be in 20 years? Well, you're solving for y. That's your future amount. So y is a variable, but that's what that typically stands for. X, which is your other variable, stands for your time. So x and y will stay x and y in your equation, but once you get to word problems, it'll say how many people will there be in 20 years? So you would plug 20 in for x. A and R are numbers that you are going to plug in. A is your same as this A. That's why we use the same letters, which is your starting amount. So A here is also the starting amount. How much do you start with? And R, well, we use the letter R for a certain reason. That is your rate as a decimal. So when I say that we have 20 people and it increases by 37%, 37% is your rate, which you first need to convert to a decimal to plug in for R. And we'll see examples of that together, so don't worry. Next, we need to talk about this plus or minus sign. It is not where you do one of them as adding and one of them as subtracting, and then you have two equations. Nothing like that. You either use a plus sign or you use a minus sign, depending on what type of problem you have. Well, we have growth and we have decay. When do you think we use the plus sign? Growth or decay? That would be growth, because you are growing, so you should add more. Whereas your decay is going to be subtraction. So it is always 1 plus the rate for growth or 1 minus the rate for decay, and your rate has to be a decimal. And because your rate is your percent, which is always out of 100, R is going to be some number between 0 and 1, which means at most you're going to do 1 plus 1 to give you 2, or 1 minus 1, which will give you 0. So inside here, you're always going to be somewhere between 0 and 2. Okay? Now, let's look at a couple of equations, and you should be able to answer some questions about that equation. So if I have the equation y equals 3 times 1.78 to the power of x, so first you should be able to answer very easily for me, what is the starting amount? If we come back to our equation information, the starting amount is a, which is the number in front of your parentheses. So your starting amount is whatever number is in front of the parentheses, which in our case is the 3. So your starting amount is 3. Next question you should be able to pretty easily answer is this growth or is this decay? And you don't have to go back and look at anything about what the equation means. You just have to remember, if you look at this number, how to tell if it's growth or decay, which you learned in 11.2. So remember, it's growth if this number is larger than 1, and it is decay if this number is less than 1. So we have 1.78, which is larger than 1. And since it's larger than 1, this is a growth. And then the last thing you should be able to answer about this is, what is the rate? Now this one is going to take the most effort to answer. Starting amount you look at right here. Growth or decay, you look at this number and compare it to 1. The rate is just R, which is just this part after it's 1 plus the rate or 1 minus the rate. So we need to use that information to answer this question. So when we have what is the rate, we know it is growth, so we know we took 1 plus the rate to get this answer. So we're going to say 1 plus R is equal to 1.78. Then you can just very easily solve this for R, because you have this 1 here, you would subtract the 1, which gives you 1.78 minus 1 is just 0.78. But then we need to turn this to a percent, because rate is a percent, so 7.78 is 78%. Let's look at a different equation. Let's say I have y equals 50, and then in parentheses I have 0.84 to the power of x. Let's answer those same questions. The starting amount. Remember that your starting amount is your number in front of the parentheses, which is 50 for us. You should be able to tell me if it is growth or decay. Remember, to tell if it's growth or decay, you look inside here and compare it to 1. If it is greater than 1, it is growth. If it is less than 1, it is decay. So I have 0.84. Is that greater than 1 or less than 1? That is less than 1, so this is a decay. And then the last one that we should be able to answer is, what is the rate? The last time I took 1 plus R equals 1.78. 1 plus R equaled whatever was in my parentheses. But this time I have a decay, so I shouldn't do 1 plus R, because that was growth over here. Now I have a decay, which means I took 1 minus the rate to give me what's in the parentheses. So then I'm going to subtract 1, which gives me negative R equals, and then you're probably going to want a calculator for a lot of these problems. And then you've got 0.84 minus 1 is negative 0.16. And then here your negative and here your negative are going to cancel out. So R is equal to 0.16, which is 16%. Let's look at y equals 12, 1.37 power of x. Let's answer these three questions. What is our starting amount? So think back to where you look for your starting amount. Your starting amount should be your number in the front, which is 12. Is it growth or is it decay? So you look at this number to tell, is it growth or is it decay? You should say it is growth because 1.37 is bigger than 1. And our rate, so it's either 1 plus r equals inside this, or 1 minus r is equal to this. Because we are growth is 1 plus the rate equals 1.37. You subtract your 1. That gives you your rate is equal to 0.37. So your rate is 37%. All right, last one like this, and then we're going to move on to a couple of short word problems that deal with similar information. Y equals 154 times 0.7 to the power of x. Answer these same questions. Your starting amount, which you should be pretty good at answering by now, is 154, the number in front of your parentheses. Growth or decay, so look at this number, growth or decay. It is decay because you are less than 1. And then your rate, so it's either 1 plus r equals this or 1 minus r equals this. Because you are decaying, it's 1 minus the rate equals the number inside your parentheses. Subtract your 1 from both sides, gives you negative r equals, and if you need a calculator to type in 0.7 minus 1, do so. You get negative 0.3. Both negatives cancel out though, which leaves you with just 0.3. Move that decimal 2 places. 1, 2. So 0.3 is 30% is your rate. All right, hopefully you have a good idea of how to do finding those few pieces of information. Now we're going to do some word problem stuff. Let me just find them real quick. There we go. So same information, just make sure you're using your word problems. So when it says the number of people that live in Piqua can be modeled by the equation below, where x is the number of years and y is the number of people in thousands. So the first question I ask you is, what is the growth rate? Okay, so that question is what is the rate? It already tells you it is growth, but also you should be able to tell based on this number being greater than 1. So because it is growth, use that to find your rate. Just like we were doing over here, it's either 1 plus the rate or 1 minus the rate equals your number. Because we are growth, we should be doing 1 plus the rate equals your number inside your parentheses. To solve for r, you subtract 1, which gives you r equals 0.05. Move that decimal 2 places to give you 5% is your rate. The next question asks you how many people are there currently. That's the same as asking you what is the starting amount. Your starting amount is the number in the front. But with this word problem, it says that y is the number of people in thousands. So how many people are there currently? There are not 21 people. There are 21,000 people. If you answered 21, the statement says the number of people that live in Piqua. You said 21, you're telling me that there are 21 people that live in Piqua. Just pause and take a moment to think if that makes sense, because it does not. Don't forget your thousands on there. Next one. The cost of a car can be modeled by our equation below for y dollars over t years. How much does it cost when you buy it? How much it costs when you buy it is the same as asking how much is it to start. It costs the number in front of $15,000. This time we don't have to do anything different. It already gave us the number just as is. It didn't say anything different up here. It didn't say y dollars in thousands or y dollars in anything like that. So it's just that number that's in front. What is the decay rate? So it tells you it is the decay. So it's either 1 plus r equals your number in your parentheses or 1 minus r equals the number in your parentheses. Since we are decay, it is 1 minus r equals 0.9. Subtract your 1. Gives you negative r equals. If you need a calculator to do 0.9 minus 1, please make sure you do so. You get negative 0.1. Your negatives will cancel out. Gives you r is equal to 0.1, and 0.1 is 10%. So your decay rate is 10%.